Alright, so in this video we will be discussing all math matrices. So, as fast as possible, we need to do matrices as fast as possible for a quick revision. So, if you have a matrix like this, minus 3, 4, 5, and this is known as a row matrix. So row, if you have something like minus 3, 4, and 5, like this is known as a column matrix. Oh, no, column matrix. And if you have a matrix which is just 0, 0, 0, 0, that is known as a null matrix. Let's just write null next to that. Null. And if you have a matrix which has the same number of rows and columns, so let's say 3, 5, 4, 2, and that is referred to as a square matrix. So square. Right. Let's clear the canvas. So now we move on to the next thing, which is addition and subtraction. So this is fairly simple. Let's just do a simple quick question. 6, 3, 5, 8 plus 4 minus 2, 0, and 7. Okay, so how would you solve this? Well, easy. You do 6 right here plus this 4, and then 3 plus minus 2, 5 plus 0, and 8 plus 7. So 6 plus 4, let's write it down. So 6 plus 4, 3 plus minus 2, 5 plus 0, and 8 plus 7, which gives us 10, 1, 5, and 15. Now, if we were to simply replace the addition sign with a subtraction sign, let's do that real quick. Oh. Let's make this a minus. Then it's the same thing. 6 minus 4, 3 minus minus 2 becomes 3 plus 2, 5 minus 0, and 8 minus 7, which gives us 6 minus 4 is 2, 3 plus 2 is 5, 5 minus 0 is 5, and 8 minus 7 is 1. So that's how you do addition and subtraction of matrices. Now multiplication. So there's two types of multiplication matrices. If there's a number outside of the matrix, such as like this is fairly simple. You simply do 5 multiplied by 8, 5 multiplied by 3, 5 multiplied by 5, and 5 into 4. Basically multiply 5 with all of these integers. So the answer would be, this is equal to 40. 5 into 8 is 40, 5 into 3 is 15, 5 into 5 is 25, and 5 into 4 is 20. So that's one type of multiplication of matrices. The other type is like this. Let's say there's a question as a matrix like this: 4, 3, minus 1, and 5. And then we have minus 2 and 6. So first we would see if we would count the number of rows and columns in each matrix. So in this we have 1, 2, 1 and 2, so we have 2 rows and 2 columns. Where here we have 2 rows and 1 column, so 2 into 1. Oh, 2 into 1. So since these two numbers are same, that indicates to us that this solving this further is possible. If these were different, like if this was 2 and this was 3, then we could not have solved it. 2 and 2. So this also shows us that these are the same, and our answer should have 2 rows, 1 column. So let's rub this off and solve it. So first, I didn't mean to rub the bracket off. Alright, you would do 4 into minus 2 and 3 into 6 minus 1 into minus 2 and 5 into 6. So basically multiply this number. Wait, it was 2 into 2 and 2 into 1. We need that. So that means that it should have 2 rows and 1 column. So we multiply 4 with minus 2 and 3 with 6. And then we do minus 1 with 2 and 5 with 6. So first number you multiply with the first row, and then when you move on to the next number in the next column, you move on to the next row. So it's like when you move on from one column to another column, you multiply with the next row after that or column. So the answer to this should be 4 into minus 8 is minus 8. 3 into 6 is minus 8 plus 3 into 6 is 18. Minus 1 into minus 2 is 2, plus 5 into 3 is 5 into 6 is 30, which gives us the answer minus 8 plus 18 is 10, so 10, 2 plus 30 is 32. That is our answer, 2 and 1. Let's just check if it has 2 rows. It has 2 rows and it has 1 column. So that is the right answer. Let me just quickly verify that. Okay, that is correct. Now let's move on to the final two concepts of matrices. Matrices, whatever you'd like to call it. So the determinant. Right. Determinant and inverse. So let's say you have a matrix so A is equal to 1, 2, 4, 5, and the question says to calculate the determinant. Well, actually instead of this, let's replace all of these with alphabets. Determinant. Let's say A, B, C, D. So you would solve this by, to find out the determinant, you would do A is equal to, actually not equal to, you would just simply do A into D minus B into C. So you multiply both of these with a minus in the middle, and that's how you find out the determinant of a matrix. And finally, we have inverse. So to calculate the inverse, you would do it like this. You have your, you can only solve the inverse after you have your determinant. So let's say you had to find out the inverse of this matrix. 7, 3, 14, 9. First, you would have to find out the determinant, which is 21. Then, in order to find out the inverse, you would do 1 upon 21. A inverse is equal to 1 upon 21, and then 9 minus 3 minus 14 and 7. See what I did? I replaced the 7. Let me use this marker. I replaced the 9 and the 7, and I put a minus next to 3 and 14. So that's how you find out the inverse. So let's quickly solve this. Would simply multiply 1 upon 21 with 9, minus 3, minus 14, and minus 7. Let's quickly write that. So 1 upon 21 into 9 would be 9 upon 21, minus 3 upon 21, minus 14 upon 21, and 7 upon 21. Now I would further simplify this, but I just don't have space, and it's pretty much how it is. That's how you find out the inverse of a matrix. And that is pretty much all you need to know for O-level matrices. I hope this video helped. It was a quick revision, and like and subscribe, share this video with your friends, and hope it helped. Goodbye.